Today I'll be presenting on a study that we did at Summit while I was there. And I'm really glad to be here in presence of the distinguished guests and the curious minds to present our study on the linkage of pre-harvest and post-harvest management practices linked with aflatoxin contamination in maize in different ecologies of Nepal. So just giving you a brief introduction or background on aflatoxins. So aflatoxins are a group of mycotoxins that are potentially carcinogenic and produced mainly by molds such as Aspergillus flavus and Parasiticus, which are more common in maize. And the health impacts are quite negative, with chronic exposure leading to high levels of stunting in children and also in extreme cases to liver cancer in adults as well. The government of Nepal regulates the level of aflatoxin as 20 parts per billion in food and then 100 parts per billion in animal feed as the safe level, which is also embodied in other different international bodies. The different factors that affect aflatoxin contamination vary from geography, different agriculture practices, and also some variety being more susceptible to the contamination during storage especially. Now giving you some research background on aflatoxins or mycotoxins in Nepal. It spans a few decades back where there was a survey that collected many food samples from different parts of the country, and they found that aflatoxin B1 and B2 were the most prevalent strains. And also the Aspergillus flavus strain was predominant in the Tarai maize. And more recently, the DFTQC, when they were collecting samples for testing, they found that at least 18% of the food samples that were coming in were heavily contaminated with mycotoxins. So since there's not been a lot of documentation on how the pre-harvest and post-harvest factors affect the aflatoxin contamination, the Summit study called CISA, it collaborated with DFTQC to understand how the pre-harvest and post-harvest practices of maize farmers are really affecting the contamination level, and also how the farmers' different storage conditions are contributing to the aflatoxin contamination in different ecologies. More specifically, our work involved assessing the level of aflatoxin in spring maize to begin with, and then we moved on to a short study on fertilizer management to see how the pre-harvest aflatoxin contamination is taking place in summer maize. Then we moved on to surveying a few local flour mills in Dang and Nuwako districts to monitor the level of aflatoxin that the farmers are keeping their maize have these aflatoxin levels. And finally, we did a storage study where we compared traditional and improved practices such as using hermetic bags to compare the levels of aflatoxin in the stored maize. So talking about the methods, results, and discussion, starting off with our initial study, which we did on spring maize. What we did was collect samples right after harvest sometime in June for the spring maize. And we did this for about 12 to 15 households in the two districts of Dang and Nuwakot, and found that about 17% of the households in Nuwakot and 20% in Dang were heavily contaminated with aflatoxins that were above the regulatory standard of 20 parts per billion. And then moving on to the fertilizer study, we wanted to see how the different level of fertilizer applications were affecting the aflatoxin contamination level. So for this, we conducted an on-farm evaluation of summer maize in different farming households. So the three different fertilizer regimens that were used were farmers' practice, which was using urea only. So on average, they used about 30 to 40 kilograms per hectare of urea. And the second treatment was using medium application of the NPK fertilizer in the ratio 60 to 30 kilograms per hectare. And finally, the high-end application was using the NPK in the ratio 120 to 60 to 40 kg per hectare. So the results for this, as you see in the graph, the maize that was from the farmers' fertilizer management practice had higher levels of aflatoxin contamination that were above the 20 parts per billion level, as compared to the moderate or medium level fertilizer application, in which all of the samples were below the level of 1 parts per billion. And same in the case of the high-end application of the fertilizer. Majority of the samples were below 1 parts per billion, and a few of the samples were in the range of 1 to 10, which is still considered safe, as a safe level of aflatoxin. One thing that was also observed was the appearance of stalk rot disease in the maize, which came from the farmers' fertility management practice, which could also be associated with the high level of aflatoxin that was seen. Before the storage study that we wanted to do, we also wanted to see how the farmers that are already storing the summer maize, what the quality of their maize was, and what is the level of aflatoxin contamination that was already there. So what we did was collect about 100 maize samples from 10 different local flour mills in Dang and Nuwakot, where the farmers were bringing in their maize for grinding from the surrounding areas. And the maize that they were bringing in, they would usually consume it themselves or feed it to their animals. And we did a small questionnaire also along with that study, in which we found out that most of the samples had already been stored for about 5 to 6 months during the summer, the wet season. And what they were doing is storing without dehusking the maize, and they were just stacking it inside their house in most of the cases. And what we found was about 52% of the samples from the Nuwakot mills and about 16% in Dang exceeded the safety standard of 20 parts per billion in aflatoxin. So then we moved on to our storage study, and we wanted to compare the traditional storage methods, which is just stacking the maize in this way inside the house or on their roofs or just outside without really dehusking or shelling the grain. And we wanted to compare it with the new improved storage methods of using hermetic bags, which have been known to store maize or other grains for longer periods of time without deterioration. And in this study, we collected 4 different brands of hermetic bags, which are available in the market, along with a regular plastic bag, non-hermetic bag, in which we put some maize grains, which were shelled from the cobs and dried immediately after harvest. But for the farmers' practice method, we still use the same method that they were using of stacking inside their house, as shown in the previous picture. And the results were kind of expected. The aflatoxin levels for all the improved practices of hermetic bags, the levels were below the 1 parts per billion level. But for the storage method of the farmers, in which they stored without dehusking, more than 50% of the samples exceeded the safety standard. So in conclusion, we found that the results from our study show the importance of improving the fertilizer application methods to contain the level of aflatoxin that is entering the maize. And also the drying and storage practices and other post-harvest practices have a significant impact on the aflatoxin contamination in any given ecology. And finally, storing maize, even while not using the hermetic bags or any other improved method, it is better to take the grain off from the cob and then drying immediately after harvest, which will minimize the aflatoxin contamination during storage to a great extent. So this is all the results that I had to show. This is a preliminary study that we're still continuing. We're also considering other factors such as germination, which will be taken upon further analysis and shared with everyone. And for this study, we would like to acknowledge the Department of Food Technology and Quality Control, especially Purna Chandra Vasti, Krishna Rai, and Suraj Shrestha for their immense support during the lab work, and also Shabnam Shiva Koti for her constant support during the study, and also the participating farmers and the flour mills from Nuwakot and Dang. Thank you for your interest.